Sure. Good day, everyone. I am Praveen Aggarwal from NIT Kurukshetra, India. Basically, I am a civil engineer. Uh, this is a work carried out by a research scholar, Ankit Sharma, and this is a paper written by Ankit Sharma and Praveen Aggarwal. IRI prediction using machine learning models. Just to give you a brief of the what is IRI and what is how we are using or what we are predicting. In fact, we are having two broad categories of payments. One is flexible payment, another is rigid payments. Flexible payments, all of us know the payments which are of bituminous payments, and rigid payments are the concrete payments. Worldwide, we are having around more than 90% of the payments of flexible in nature, and only 10% of the payments are of rigid payments category. In flexible payments, there are different types of distresses. There are potholes, there are cracks, there are ruttings, there are showing, there are shovels. All those are the different categories of distresses that are there in case of flexible payments. And there is basically we can classify different type of distresses into two categories. One is functional distresses, another is structural distresses. One of the functional distresses is IRI. IRI means International Roughness Index. Undulations. You might have observed at some point of time that we are traveling on a road and we are not moving very fast, but we are feeling that as if we are moving very fast because of the uneven surface of the road. And at the other on the other end, sometimes road is so smooth we are moving at a faster pace, but we do feel like we are not moving at that fast. So that is because of the smoothness of the road. So by doing this exercise, what we have tried to correlate, we try to correlate the different type of distresses, and using those different type of distresses, we try to work out the IRI, International Roughness Index, of a particular payment. The content of the presentation includes objectives, data presentation, input parameters, visualization, machine learning models, methodology, results, and finally conclusions. As I said, we have a huge road network right now of the tune of 64 lakhs kilometer in 2019, growing at a very fast pace. 75% of the 71% of the roads are of rural road category. Payment are payment evaluation is basically carried out right now on judgment basis or on visual basis. Not very logical or systematic approaches are being used for the maintenance of the payments. An ideal payment management system should integrate the evaluation of all distresses simultaneously. This is what we are looking for. Visual inspection by field engineers are a comparatively easy way of doing the evaluation of the payments, and unevenness is normally required to be evaluated using sophisticated equipment. So we try to correlate the usual visual inspections with the replacement of sophisticated equipment required to work out IRI. So the objective of the study is to collect the payment data for climatic regions similar to Indian conditions from LTPP database, to observe the basically LTPP is a long-term payment performance database developed by US. So I will be showing the various screenshots of the how we have collected the data from this website. Second objective is to observe the variation of the responses variable in terms of input variables for understanding and interdependency of variables. Next, to evaluate applicability of machine learning models for accurate prediction of IRI, that is International Roughness Index, and to compare different models on the basis of statistical parameters, that is root mean square value, root mean square error, all those terms. Now the LTPP, basically this is a website from where the data is available, managed by government of US. Uh, they have a huge database for different categories of roads, roads of flexible nature, roads with rigid payment, roads having a regular maintenance, roads those where there is no maintenance, roads which are on a clay subgrade, roads which are with a high traffic, roads in a rainy season, roads in a snowbound areas, all those categories of roads are there. So we have picked up those data, or we have filtered those data which is similar to that of Indian geographical or topographical categories. So these are the various screenshots from where the data of the road segments have been collected depending upon the category of base. So all type of base, bonded base or unbonded base. Then the payments which have been regularly maintained, or which have been not, which not, those payments which have not been maintained since they have been constructed. So that way, then the type of subgrade, coarse graded or fine graded, because the performance of the payment depends upon the type of subgrade. Then the dry region or freeze zone or no freeze zone, or wet region or freeze zone, non-freeze zone. So all those filters were applied in order to find out the data. Flexible payments, rigid payments. So because we have worked on flexible payments, we have extracted data corresponding to the flexible payments. So after having all these data, we filtered, applied different filters and extracted the data relevant to our study. So these are the different parameters which have been collected. We have classified them as a name of the variables. If I say these are the, sorry, these are the, is there any pointer, sir? These are the variables which are of physical, representing the physical distresses in the payment. This is representing the structural value of the payment, design life of the payment, category and type of payment, precipitation and total temperature, annual temperature of the payment means the topography of the area, depending on the topography and rainfall of the area, initial IRI, age of the payment, and final IRI. So this is the output, and these all are the inputs on the basis of which we are trying to work out output. This is just to give you a feel of how IRI varies with different input variables. Variation of IRI with structural number, with cracking percentage, again with length of cracks, with longitudinal crack length, with wheel path cracks, with design life in terms of vehicles, thickness of the subgrade or base course, thickness of the asphalt pavement, mean temperature, the variation, and the precipitation, variation of IRI with precipitation, variation of IRI with the initial IRI. Of course, initial IRI, say every time it is going to be higher on the from the initial IRI, because over a period of time IRI is going to decrease, or it's going to deplete. Variation of IRI with the age. So these are the three models or three machine learning approaches which have been used in the present study. One is linear regression, second one is optimized tree, and third one is optimized Gaussian process regression, known as GPR. Basically, all these three techniques have been applied using MATLAB. In the linear regression, linear variation between the dependent and the independent variable is obtained. And using those, we have obtained the least square or all the other statistical parameters. In case of optimized tree, basically tree method of machine learning is generally used for classified problems. Tree can be applied for regression problem by reducing it into smaller classified problems. Regression tree has been optimized using Bayesian optimization technique. In case of GPR, optimized GPR, Gaussian process regression, is a non-parametric Bayesian approach for solving the regression problems. It captures the relationship between the predictors and the responses using kernel functions. This study used Bayesian optimization to choose the best hyperparameter for optimal model performance. In Bayesian optimization technique, basically technique is used to look for the best possible values of the input hyperparameters for machine learning models. This optimization is preferred when the selection of the hyperparameter is huge and it is not computationally possible to find out the best performing hyperparameters in the polynomial time. One of the key benefits of Bayesian-Poisson optimization technique is its capability to balance the trade-off and the exploration between in the variable solution space. So this is the methodology which is being followed: data collection, preparation of data using the data in the MATLAB, and applying the three modeling techniques and working it out on the basis of statistical parameters. These are the results which have been obtained in terms of statistical parameter using the three regression techniques or three modeling techniques: linear regression, optimized tree, and Gaussian process regression. And out of these, the Gaussian process regression shows slightly edge over the other techniques in all statistical parameters. Representing the IRI close to 0.9, that is 0.88, 0.89, and root mean square error also very less as compared to other techniques. A few observations. The GPR model, when optimized using Bayesian optimization technique, performed best out of the three models that used. It is observed that in case of optimized tree, Bayesian optimization technique does not contribute significantly in this study when compared with fine tree. In the present study, regression R square, the coefficient of correlation is obtained as 0.83, and as compared to other models, it is 0.8. These are the pictorial representation of observed as well as the predicted IRI value. The first one using linear regression, the second one using optimized tree, and the third one using optimized GPR. Conclusions: various machine learning models can be used to predict IRI value of the pavement composition, visual distresses, traffic, age, IRI, initial IRI, and climatic data with a fair degree of accuracy. GPR model, when optimized with Bayesian optimization technique, performed best out of the three modeling techniques considered in the present study. It is observed that in case of optimized tree, Bayesian optimization technique does not contribute significantly in this study when compared with fine tree. In the present study, linear regression, that is R square 0.83, was performed better as compared to optimized tree. Bayesian method of optimization is useful tool for optimizing GPR as it automatically searches for the optimized hyperparameter in the solution space. These are the references which have been included in the present study. And of course, we have used the data from the LTTP website and we have filtered it so that we can use it to simulating the situation prevailing in India. Thank you. I'm open for queries. Sir.